In this video, we are going to discuss one of the concept of atomic physics, right? So, when I talk about atom, I will say that atom is a tiny particle and an indivisible particle. When we see the composition of the atom, that means from which atom is composed of, the constituent particles of atom is proton, neutron as well as electron, right? Among these three, I am going to concentrate only on the electron, since our discussion is very related to electron, that is Millikan's oil drop experiment. So, in 1897, J.J. Thomson discovered the electron. Right? He said that electrons are negatively charged particles which are present in an atom, but he did not give any numerical value for the negative charge of that electron. That means how much of the charge electron has. He did not give any numerical values. He failed to give that numerical value of the electron. But later, after a few years, I think in 1913, Robert Andrew Millikon and Harvey Fletcher are the scientists who will able to find out the charge of the electron. They used a very clever technique. So believe or not, they used oil. By using clock oil, they will able to find out what is the charge of the electron. That means how much of charge an electron has by using clock oil. And this is our discussion, that is Millikan's oil drop experiment. In this video, we will understand how they able to find out the electron, the charge of the electron by using oil. So when we see the experimental setup, this is what the experimental setup I think is a cross section of the instrument what they are used, or operators what they are used. Well, first we will understand what is the experimental setup, and then we will move forward that what is the experimental procedure. So when I talk about your experimental setup or Millikan's oil drop experimental setup, they has two parallel plates. These are the two parallel plates. The upper plate is poured. Upper plate is poured in the sense it has some hole, and this is a lower plate. So these two plates are separated by an insulating glass material. They are separated by insulating glass material. The upper plate, it has some hole, and this is one of the chamber. This chamber is enclosed by another chamber C, in which the oil is flowing. Oil is floating in circularly. Circularly, oil is flowing at constant temperature. Why we have to maintain a constant temperature? Because so if you do not maintain constant temperature, that temperature directly affect the density of that oil particles or density of the oil droplets. Whenever there is a variation in the oil droplets, of course that is directly affect to mass. We are using mass of a single oil droplet to find out the charge of the electron. Whenever there is a variation in the mass of a single oil droplet, we can't able to find out exact value or a value of the charge of the electron. That's why we are maintaining a constant temperature. This is one of the chamber. So this is having an atomizer. This chamber is connected to atomizer, and that atomizer containing clock oil. So clock oil, and we are using a telescope and a source of light to view the oil droplets through microscope. We are using a source of light, and we are using X-rays to ionize the gas particles in this chamber. And why it is so, I will discuss in the later. And so this upper plate is connected to high tension positive voltage, high tension positive terminal, and the lower plate is earth terminal. Here we have an atomizer, and this is what the nozzle of the atomizer. This is the lower inner chamber, this is the outer chamber. This is what an experimental setup of Millikan oil drop experiment. Now we will move on to the theory of your Millikan oil drop experiment. That means how they able to find out the charge of the electron. They use it by seeing the motion of the oil droplet. By observing a motion of single oil droplet, they will become success in finding out the charge of the electron, that is E. They will be able to find out what is the charge of the electron by observing what the motion of the oil droplet in this chamber through telescope. Through telescope, they will be able to find out the charge of the electron. So the motion of the oil droplet we will discuss in two cases. Right? We will discuss in two cases. Let me discuss one by one. And one case, the motion of the oil droplet only in the presence of gravity, that is force of gravity. Only in the presence of gravity, what happens to the motion of the oil droplet? I am going to a single oil droplet. This is a single oil droplet which they are focused in a telescope by using this light. By using this light, this is the oil droplet what they are observed through telescope. So by observing, they will find out that this oil droplet is influenced by gravitational force. Of course, it has some mass, it has some weight, Because of that weight, it is influenced by gravitational force, and that was Fg. Fg is the gravitational force, that is mg. Right? Mg is the gravitational force which pushing that oil droplet downwards. This gravitational force will pushing oil droplet downwards, whereas thus that medium has viscous force. Thus that air medium has some viscous force, and that viscous force was pushing oil droplet upwards. That means it was not pushing upwards, it was opposing the motion of this oil droplet. It was acting in the opposite direction of the gravitational force. Whenever at equilibrium condition, at equilibrium condition especially, this viscous force become equal to this gravitational force. When the two forces become equal, this oil droplet will going to attain a velocity, and that velocity is what we know as terminal velocity. Whenever this mg, that is gravitational force, become equal to the viscous force. Of course, this is an equation where you derive by using Stokes' law. That means what is the force acting on a particle in a viscous medium? By using Stokes' law, we can able to give an equation 6 pi eta AB, where eta is the coefficient of viscosity, A is the radius of this oil droplet in this case, and V is what? The velocity attained by this particle, attained by this droplet, because of these two forces become equal. Right? Whenever these two forces become equal, it is going to attain a constant velocity or a steady velocity, and that velocity is termed as terminal velocity, and that is V. That is what? V. And now this is called as equation 1. Now call this as equation 1. So by using these two, we can able to find out what is the mass of that oil droplet, effective mass of that oil droplet, and radius of that oil droplet. So by using this equation, we can't able to, because directly we can't able to, we have to modify this equation. How? We have mass. This mass is related to density, and density is equal to mass by volume. Therefore, mass is equal to density into volume. I'm going to use that, right? And this is equal to, what is the volume of that oil droplet? That is spherical in shape. Therefore, volume of the sphere is 4 by 3 pi a cube rho minus sigma into, this is what mass. Right? We have mg here. That is, we can write that 4 by 3 pi a cube sigma minus rho minus sigma into g is equal to 6 pi eta av. 6 pi eta av. Here rho is the density of the oil particle, but sigma is the density of that air medium. This is an air medium. That air medium has some density, and this will give the relative density what we need. The relative density. This is a relative density. But when you take a single term, sigma is the density of oil droplet. Rho is the our density of that oil droplet. Sigma is what? Density of air medium, and the differences will give relative density. How you write that? So I will give the clarification. That is, whenever this oil droplet is under the influence of gravitational force, the viscous force will oppose us. At the same time, there is an upthrust force which also opposes the motion of that oil droplet, motion of oil droplet. That you can say that force of buoyancy also opposes the motion of that oil droplet. That's why I will, and that force is given by rho, right? Rho Vg. This is what? Force of buoyancy. It also opposes the motion of that oil droplet, plus viscous force. This is viscous force. Now these two are acting upward. Opposite to the direction of mg. That is mg. Therefore, mg is equal to, I'm going to transfer this here. Mg is equal to 6 pi eta a. Now g common. M can be written as how? 4 by 3 pi a cube sigma minus rho. So this was sigma. This is sigma. That is what? Force of buoyancy, sigma. And this g is common. This is v. V is also that is what? That is spherical in shape. That is volume is v. Volume is given by 4 by 3 a cube sigma into is equal to a. And this can be altered by taking common factor. I will write 4 by 3 pi a cube, g is also common, rho minus sigma into g is equal to 6 pi eta ab. This is what the equation we will get. This is what the force of buoyancy also involved. So for our understanding purpose, I said that force of buoyancy. In examination perspective, you can write this is an equation. For this equation, you can write this equation as per your examination is concerned. For understanding skill, you need that force of buoyancy also opposes this motion. Now after finding, that is after equating this to this, through this equation, I can able to find out what is the radius of the oil droplet. After finding radius of the oil droplet, I can able to find it what is the mass of that oil droplet. So to find out radius of the oil droplet, I am going to make that a get cancelled here, pi get cancelled here. Therefore, I will be left with a square is equal to 18 by 4 eta v divided by rho minus sigma into g. Here 2 1 2 9. A is equal to square root of 9 by 2 eta v rho minus sigma g, or you can say 9 by 2 eta v divided by rho minus sigma g whole raised to the power of 1 by 2. This is what the radius of the oil droplet, what we are observing or what they are observing through microscope. This is radius of the oil droplet. By using this radius of the oil droplet, I can able to find out what is the mass of that oil droplet by using this equation. Right? By using this equation, that is m is equal to density into volume. Density is nothing but so by using this equation, by using this equation, I will write. This is what the radius of the oil droplet, what they are observing through telescope, right? By using this radius, I can able to find out what is the effective mass of that oil droplet. What is the effective mass of that oil droplet? So to find out the effective mass of that oil droplet, I am going to use this equation, that is m is equal to 4 by 3 pi a cube into rho minus sigma. Therefore, m is equal to 4 by 3 pi. What is the value of a? This is what the value of a, 9 by 2 eta v divided by rho minus sigma into g whole raised to the power of 3 by 2. That is 1 by 2 into 3 is 3 by 2. This is what the effective mass of the oil droplet. This is what the effective mass of the oil droplet, what they are observing through telescope. This is what one of the condition. This is one case for the motion of the oil droplet only under the influence of force of gravity. So when I apply electric field, that is second condition for the motion of the oil droplet. When I apply electric field, so the oil droplets which are enter this hole through the nozzle of the atomizer has some charges. They have already has some charges. Why they have some charges? Because of the frictional force which is existed in the nozzle of the atomizer, they already associated with the some charges. That means frictional force will going to make the oil droplets to be charged. Frictional force will going to make the oil droplets to be charged, and that oil droplet has some n number of charges, as n1 number of charges when they are entered into the hole through the hole by the nozzle of the atomizer. When I apply the electric field, these charged particles are influenced by the electric force. I am applied electric field along these two plates, and these oil droplets which are charged, having some charges, are influenced by the electric field what I am applying. Therefore, I know electric field is nothing but force per unit charge. In this case, electric field is nothing but force by n1 number of charges of oil droplet what we are observing. This is the oil droplet what we are observing. Under the influence of electric field, it was influenced by electric field in upward direction, and of course force of gravity in downward direction. Alright, force of gravity in downward direction. Therefore, N1E is equal to force, this is a force which is acting upward. This force will pulling or will pushing that oil droplet upward, right? And at that time, this is going to attain a velocity v1, right? Through velocity v1, it was moving upward because of the electric force. What they are applying. At this time also the gravity, the force of gravity is there. At this time there is a force of gravity. So this is in the upward direction. Here we have force of gravity minus mg is equal to what? 6 pi n eta v1. Sorry, 6 pi n eta v1. So this is what the force, electric force, which is pushing this oil droplet upwards, and this is force which is acting downward. That is, there is a difference. And that is equal to viscous force. This viscous force is also in the downward direction. That means this viscous force will avoiding the motion of this oil droplet which is moving upward. It opposes the motion of this oil droplet which is moving upwards, right? These two forces are in a downward direction. This is a force which is in upward direction. First you can write that is equal to mg plus 6 pi eta av1. These two are in opposite direction, the upward direction. These two are in downward direction. This is in upward direction. So when I make it in that is mg is equal to 6 pi eta av1. Call this equation 2. Right? This is an equation 2. This is because of the oil droplet having n number of charges. n1 number of charges. So by dividing this equation 2 by equation 1, what we have, that is mg is equal to 6 pi eta av. This is what equation 1. I am going to divide this equation 2 by equation 1. What I will get? This is equation 2. Remember the equation 2. That is E n1 E minus mg is equal to 6 pi eta av1 divided by mg 6 pi eta av. Here these all terms cancel. Here E n1 E divided by mg minus 1. mg by mg is 1 and v1 by v. Therefore E n1 E is equal to v1 plus v divided by v into mg, and E is equal to n1 E is equal to mg divided by ev into v1 plus v divided by v2. This is what the charge of the electron. That means that oil droplet having n1 number of charges. By using this equation, we can able to find out the charge of the electron. When there is no and that means that oil droplet has some charges because of the frictional force in the nozzle of the atomizer. At same condition, when I apply electric field, when I illuminate X-rays, that X-rays are going to ionize the gas molecules in this region. In this region, we have a gas molecules, and that gas molecules are ionized by the X-ray what they are illuminated. Right? When they undergo ionization, this oil droplet has some charges N1. Right? After ionization, this oil droplets also gain some additional charges, and that charges is given by N2, and that charges is N2. Right? Whenever after ionization, that oil droplet gains some additional charges. Right? And after gaining some additional charges, it was moving in the upward direction with a velocity v2, and I will charges N2. After ionization through X-rays, after ionization of gas molecules through X-rays, that oil droplet gaining some charges. Already it has some charges, and into that we have it going to gain additional charges, and that was represented by N2, and it changes automatically. When it acquires additional charges, it going to changes the velocity of that oil droplet. The velocity of the oil droplet will changes, and that was represented by V2. So when I apply this two equation to get that N2, I am going to replace N1 by N1 by N2. That is mg divided by ev, v2 plus v divided by v. So v2 plus v divided by v. This is what the other equation. By making these two equation differences, that is called this equation 3 and call this equation 4. By making difference of 4 minus 3, we will get an equation. We will get equation N2 minus N1 into E is equal to mg divided by ev minus or into V2 minus V1. This is what the final equation what we have. Right? This is what the final equation they get. So this is V2 is the velocity when it acquires additional charges. V1 is the velocity of that oil droplet moving in upward direction whenever there is no additional charges. That means ionization of that gas molecules doesn't take place. Here N2 is the number of charges after ionization. N1 is the number of charges associated with that oil droplet when they are entered into this region through the hole. So by this equation they will be able to find out what is the charge of the electron. Right? That means they did at this condition when V2 is greater than V1. This implies this N2 minus N1 become what? Positive. V2 greater than V1 and V1 less than when V2 less than V1, this N2 minus N1 become negative. That means this representing the charge. N1 minus N1, N2 minus N1 representing the charge. When V2, that means when this velocity is greater than this velocity, that charge become positive. When this velocity is greater than this, less than this velocity, that charge become negative. That charge become negative. That means what I am going to convincing you that we have both the charges, both the positive charges and the negative charges after ionization. After ionization, we have both positive charge as well as negative charge. That's why in further I am going to make this equation as plus or minus. Plus or minus. Both positive charge as well as negative charge as same magnitude, but the sign is different. That's why whenever this, that means V2 is greater than V1, we have positive charge. We have positive. This become positive. Whenever V2 is less than V1, we have negative. We have both the condition. That's why I am representing plus or minus mg divided by EV into V2 minus V1. So when they are demonstrating experiment, they did 100 of trials. 100 of trials. In 100 of trials, they get one value which is minimum, which become minimum. That is V2 minus V1 become minimum. V2 minus V1 become minimum. That means they did 100 of trials. In 100 of trials, when they see the values of V2 minus V1, among that 100, one value is very minimum, and that is integral multiple of other 99 values. That is integral multiple of other 99 values. So whenever V2 minus V1 is equal to minimum, at that condition this N2 minus N1 become 1. N2 minus N1 become 1. So N2 minus N1 is 1, and I am going to apply V2 minus V1 by V2 minus V1 minimum. This value I am going to apply in this, and this value I am going to apply in this. So finally we will get N2 thus N2 minus N1 is removed by 1 into E is plus or minus mg divided by EV into V2 minus V1 is V2 minus V1 minimum. This is a one value of the velocity difference of the velocity difference of that oil droplet which is moving in upward direction. When I apply V2 minus V1, I will get a value. So we will apply the value of M1. Yes, finally we have that equation. We get an equation E is equal to plus or minus mg divided by EV into V2 minus V1 minimum. Now just by applying the mass, we already derived the effective mass of that oil droplet. I am going to substitute that value, what I get for the mass of that oil droplet in this equation. I will get plus or minus G EV into mass is that is 4 by 3 by 9 eta V divided by 2 into rho minus sigma into G whole rise to the power of 3 by 2 into sigma rho minus sigma into V2 minus V1 minimum. Now just by my using basic mathematics, I will write that E is equal to plus or minus 4 by 3 by 9 eta by 2 whole by 2 to the power of 3 by 2. This V here 1 we get cancelled. This become cancelled. This cancel. Therefore this G cancel. V divided by 2 sigma minus rho G whole rise to the power of 1 by 2. Whole rise to the power of 1 by 2. That is V2 minus V1 divided by E. V2 minus V1 minimum. And this is what the final equation through which they discovered or they find out the charge of the electron, the negative charge of the electron, the numerical value for the electron, and they will get E is equal to 1.59 into 10 raised to minus 19 coulomb. 10 raised to minus 13 coulomb by applying V2 minus V1 minimum. If they apply V2 minus V1 other values, they will get what values we should expect. If by applying V2 minus V1 minimum value, if they get E is equal to 1.5 into 10 raised to minus 19 coulomb. If they apply V2 minus V1 other values, what happens? They will get the value that is 1.59 into minus 19 coulomb. The integral multiple of this thing. This is the charge of the electron. This is Q. Q is equal to integral multiple of the charge. This is one of the that is quantization. Charge to be quantized because the charge is the integral multiple of the charge of the electron. If they apply other values of V2 minus E1, they will get 2 into same value, 4 into same value. That is integral multiple of the same value. Right? And they will confirm it. This is what the charge of the electron. And many people did a lot of research, efforts. Put a lot of efforts to find out the charge of the electron. And now one of the universal accepted value for the E is E is equal to 1.602 into 10 raised to minus 19 coulomb. This is what a universally accepted value. And this is how they discover, how they are able to find out the charge of the electron by using clock coil. Of course, why they use clock? This is why they use clock coil, because clock coil is volatile. It is a non-volatile in nature. If they use other than clock coil, other liquid like water, it is generally volatile in nature. It has low vapor pressure and it will be easily evaporated. We are applying electric field. That means that electric field going to generate heat. Right? Whenever that going to generate heat, the water molecules, the water particles, especially water droplets, are going to evaporate. It is generally volatile in nature, that do not tolerate that much of heat. That's why they used oil to find out the charge of the electron, which may be tolerant, which is non-volatile in nature, and tolerate to the temperature, tolerate to that heat because of the electric field. And this is how they are able to find out the charge of the electron. And thank you for watching this video.